Hello everyone, we are from class 3A of Sayadri College of Engineering and Management. I am Aparna Baliga.
And I'm Shivani.
And I'm Shannon. I'm Disha.
Today we will be explaining a simple code, assembly code, which will be basically for moving elements of array 1 to array 2 on 8086 architecture.
Hello everyone, I'm Disha. I'll be giving the introduction about DOSBox software. What is DOSBox? DOSBox is a free and open source emulator which runs software for MS-DOS compatibility disk operating system, primarily video games. It was first released in 2002 when DOS technology was becoming obsolete. Its adoption for running DOS games is widespread, with it being used in commercial re-releases of those games as well. How to install DOSBox? These are the steps to install DOSBox, and the link of DOSBox is given in the description. History. The development of DOSBox began around the launch of Windows 2008. Windows NT System, when its creators, Dutch programmers Peter Wenstra and George van Rieber, discovered that the operating system had dropped much of its support for cross software. The two knew of solutions at the time that they couldn't run with applications in window mode or scale the graphics. The project was first uploaded to SourceForge and released for beta testing on July 22, 2002. Features. DOSBox is a command line program, configured either by a set of command line arguments or by editing a plain text configuration file. For ease of use, several graphical front ends have been developed by the user community. Since 2011, the developers of the Wine compatibility layer have integrated DOSBox into Wine to facilitate running DOS programs that are not supported natively by the Wine virtual DOS machine. Since January 2015, the Internet Archive has added thousands of DOS games to its software library. As of October 2019, the DOS library contained 6,934 games.
Hello everyone, I'm Shivani and I'll be explaining the instructions to open and execute a file in DOSBox. So first we need to mount the file. So we use mount space C colon DOSBox/8086. Here 8086 is the microprocessor name. Now you can see that the drive C is mounted, and to link we use C colon. Now the drive is linked. Now in order to open the file we use edit space hello.asm. Here asm is a file extension and hello is the file name. Now it will be explained by Aparna.
Hello everyone, I am Aparna Baliga. I'll be now explaining the assembly code involved with this.
You can see here on the screen, I have already written the assembly language code for 8086 architecture. Okay, so the main motive of this code that is already displayed is to copy the contents of array 1 to array 2. So for that, we need to first initialize all the data that are required for this copying operation to take place. So as you can see here, we have the X segment. So this X segment is containing the data. So array 1 is initialized with 4 elements. So these are the contents that belong to array 1. And it has to be copied to array 2, so therefore it doesn't have any elements. So the contents are empty, there are no contents. And next, for the operation to take place, we require count variable. So since the number of elements in array 1 is 4, here the count has been initialized to 4. Next, we come to Y segment. So the Y segment consists of the actual code that is required in order to carry out this move operation. So here the code begins by assuming that the Y segment is CS, this refers to code segment, and DS, the data segment, is the whole Y segment. The whole X segment. Okay, so the X segment refers to the data segment and the Y segment is the code segment. Next, let's come to begin. So here begin, back, they all refer to the labels. So in begin, we have these codes. So let us get to know what this code actually means. So first, this line of code, it moves the contents of X, the data that is stored in the X segment, to the register AX. Next, this whatever is stored in AX has to now move to DS, that is data segment register. So it is the same thing that we had already discussed, that is assumed thing. So here the code, the data that is there in the X segment is first moved to AX register, and whatever is stored in AX register is accessed, has to be accessed by the data segment, so it is moved to data segment. Okay, next we have these three line of codes. So this sets up pointers to the beginning of array 1 and array 2. So SI is source register and DI refers to the destination register. So this sets the pointer, offset array 1 is moved to SI, sets a pointer which is pointing to the first element, which would be pointing to the first element of array 1, and this move DI offset array 2 would set up a pointer which would be pointing to the first element of array 2. Okay, next move CX, 4. So we had already initialized a count variable which had value 4. Now we would be moving this value 4 to a register CX. Next, that is back labeled. Back labeled code consists the following code lines. So this has to be repeated in order to copy each element of the array 1 to array 2. So a loop has to be executed such that one by one the first element gets copied, the second, the third, and then the fourth. So here the first line, the content of the pointer which is pointing to that particular memory address has to be accessed, and it has to be moved, it has to be copied to AX register, and then from that AX register it has to be moved to the pointer which is pointing to the first memory address of array 2. So it is like loading the value at the memory address that is pointed to by SI, and it is stored it at the memory address that is pointed to by DI. So this is what the two lines of code explains. I hope it is clear. So this brackets refer that the contents of whatever is present at that particular memory address. So now we know that it is pointing, the SI is pointing to the first element of array 1. So the contents of that memory address is first stored in AX register, and then whatever is stored in the AX register, it has to be moved to moved to that pointer. So now the pointer of array 2 is pointing towards the first element of the array 2. So it has to move to that place. So this operation does that. So now, so the first element which is present in array 1 is placed, is copied, is moved as the first element of array 2. Next, in order to access the second element, so we need to increment the pointer. So incrementing SI twice and incrementing DI twice, because so the array, each element of the array is of 2 bytes. So incrementing it twice. Next, this process has to be repeated. So for that, this decrement CX value was initially 4. So it has to be made 3 such that the loop repeats 2, 1 until all the elements of array 1 gets copied to array 2. So once it is decremented, so initially it was 4, now decrementing makes 3. And then next is J and Z back. What does a J mean? What does J and Z mean? Jump, if not 0. So the value from 4 has been decremented to 3. It is not equal to 0. So the jump action takes place such that the control comes to this line of assembly code. So once more, this now the accessed element would be the second element of array 1. The second element of array 1 would be copied as the second element of array 2. So once more, the same step takes place. Now 3 count gets decremented to 2. So it is not equal to 0. Once more, the loop gets executed. Now 2 gets decremented to 1. It is not equal to 0. Once more, it would be executed. The loop would be executed. And now decrementing CX, which has value 1, would lead to it becoming 0. So 0, it is 0. So jump action does not take place. It does not come to back once more. So it comes out of this back. So it comes out it exits from the loop, so the loop terminates, and these two lines of code that you can see, the value of AH 24CH. So it is for the termination of the program. It is the exit code actually, which is for the termination of the program. And here int 221H. So it makes a software interrupt. It is for a software interrupt that has to be generated to exit the program. Next, Y ends, the code segment ends, and end begin. So overall, so this is a code that explains on how the contents of one array has to be copied to another array. And the code that you can see is an assembly language code, which is on an 8086 architecture microprocessor. Hope you are clear with this. Thank you.
So now I will tell you the steps to execute the file. First, MASM space file name, that is hello.asm, is used to compile the file. Then you need to click enter a couple of times until you get 0 warning errors and 0 severe errors. Now we need to link the file. We use link file name .obj. Here obj is the file extension, and now you need to click enter a couple of times until you get no stack segment. Then to execute the file we use hello.exe. Here exe is the file extension and hello is the file name. Now nothing will get printed because there is nothing to be printed. And now to debug the file we use td space hello.exe. Here exe is the file extension and hello is the file name, and td is used to debug.
Hello everyone, I'm Shannon, and today I'm going to be explaining about how to debug this particular code which we have typed in DOSBox. Hello, I'm Shannon, and today I'm going to be explaining about the terminal in DOSBox. So to open the terminal, you need to do td space file name. My file name is hello, so I'm just going to be using hello. So yeah, this is the terminal. And here, as you can see in the terminal, there are certain things that you need to understand. This is flag. This C is equal to 0, Z is equal to 0. All of this is the flag. And these AX, BX, all of these are called as general purpose registers. So basically 16-bit registers. So these are used to store values temporarily, like usually during a move operation or something. So next, these code that you can see here, move, this is basically human interpretation. We know the language like this, but the machine understands the same language in the form of this. So here there is the opcode and all that. So from here the machine language understands it, and not clearly like this actually. Still, to simplify this, the machine goes through symbols. So these symbols, as you can see here, these are the way that the machine actually understands the language. So if the machine has to understand anything, it converts it into ASCII and then it understands. So this is just a brief about how things start. And SI here is the source and DI is destination. All these are just like registers. To run the code in these terminals, it runs the code step by step. So basically, if you need to run the code, you need to use function key and F8. So here, as you can see, the first instruction, that is this, is already executed. So AX 48AD is moved to AX. Next, when I press function F8, this code, this line code has to be executed. For that reason, we'll just use function F8. Now you can see this EX value, currently EX was 0 and 48AD has gone and stored in EX, and from there it came to DS. So now you can see that the DS value is updated. And the next instruction is move SI 000 to SI. So that is not visible here because since it is already here, it might not change. Yeah, it has not changed. But that's okay. I can show you that 0008 is moved to DI. When you press function F8, yeah, the DI value is incremented to 0008. So this is what happens. And next, CX value is used to store the counter. So since this is a 4-bit operation, like I'm moving 4 elements from array 1 to array 2, I'm going to be using CX to do 4. So I'm initializing 0004 and setting CX. So when I press function F8, you can see that the CX value is already incremented. So from here, the actual code starts from how to move the array elements from one array to another. So the contents of SI has to be moved to AX. In the code mentioned by Aparna, the contents from SI, so the first content on SI was 4142, that has to be moved to AX. So when I press function F8, yeah, you can see that AX is updated to 4142. Similarly, the AX value has to go and set in the contents of EI. So that is the move operation. From here, the code actually moves. So you can't see the moving operation here because this is just the address of the DI register, but in the actual contents it has already been changed. So next you need to increment SI and DI. So yeah, SI is incremented to 1. When I press this once more, SI is incremented to 2. And next, since DI is 008, it has to move to 9 and 8, which I can show you. Yeah, it has moved to 9. And now it is moved to 8. And here the flags also keep on changing according to the code. So next, I need to decrement my counter value. So when I press function F8, yeah, the counter value is decremented from 4 to 3 in CX. And now it will check if it is 0 or not. If the counter value is 0, then it will move to the forward code. Or else it will loop. It will loop back to wherever we gave the instruction. So the instruction was actually contents of SI is moved, so that instruction will be executed. So see, let's come back to move AX comma contents of SI. So this thing goes on repeatedly. So before the counter value is changed, this currently 0003. When I change it, it becomes 0002. That means the decrement option has taken place. And now again it will check if 2 is equal to 0. Now 2 is not equal to 0, so it will loop. And so this thing repeats. Now in my AX value, I have 4141, which is according to the code. And yeah, the same operation goes on bit by bit. That means like each value is shifted from the array. Like the first value is shifted from the array 1 to array 2, then the second value, and so on. So next, yeah, now my current counter value is 002, and it has to change to 1. It has to decrement. So it has decremented to 001. And again, jump no 0, it will check if the counter value is 0. If not 0, 1 is not equal to 0, so it will loop. This is actually supposed to happen 4 times. So for the 4th time now, you can see the counter value is 1 currently. So now it becomes 0. That means the counter is completely decremented. Meaning that all the elements have already moved from array 1 to array 2. So now it will go to these further codes. So what happens is when I press function F8, it has moved to the forward code. And these codes, these two last codes, AH4C and 21, this is to just terminate the operations and to tell the machine model that it is done, to tell the code that it is done. So function F8, yeah, so this is like the final step. And once everything is done, it shows terminate. If you want to execute this again, you can press function F8 again, so you get this pop-up. You can press yes, and you can continuously do this as many times as you like to see the step-by-step operation of how the machine level language moves on. So after this, you can exit. To exit, you can use alt text or you can directly do the file. Thank you.